Hello dear students, today we'll see linearization of non-linear relationships. Now many a times the data in engineering fields is non-linear. For example, it is given in the form of exponential equation, or sometimes it is given in the form of power equation. Now we have already discussed polynomial regression, where we can fit one second order curve. So same thing we can use here, but a simpler alternative to using this polynomial regression is to use some mathematical manipulations to transform these equations into linear form, and then we can use simple linear regression for fitting the data. So here this equation for exponential function is y is equal to alpha 1 e raised to beta 1 x. So now this equation can be linearized by taking natural log of this equation. So after taking natural log, we will get ln, that is natural log of y, is equal to natural log of alpha 1 plus beta 1 into x and natural log of e. So we all know that natural log of e is equal to 1. So the equation becomes ln of y, that is natural log of y, natural log of alpha 1 plus beta 1 into x. Now this equation is a linear equation where natural log of y is varying with respect to x. So here we can draw the graph x on the x-axis, y-axis will take ln of y. Now we'll get one linear relationship between these two. So this line will be like this. Okay, this is the equation for this line, and here this equation is similar to y is equal to mx plus c, or our equation for linear regression y is equal to a0 plus a1 x. Y means here log of natural log of y, a0 is natural log of alpha 1, and beta 1 is a1, here x is x. So this natural log of alpha 1 is the intercept. So here this value, it is the intercept, and this is natural log of alpha 1, and beta 1, what is this? This is the slope, like this. So this slope is beta 1. Okay. So now using this relationship, ln of y is equal to ln of alpha 1 plus beta 1 x, we can find out the values of this ln alpha 1 and beta 1, and then we'll get the relationship in linear form, that is natural log of y versus x. Okay. Similarly, we can linearize this power equation, that's y is equal to alpha 2 into x raised to beta 2. So here we will take log to the base 10 to this equation. So what will happen? Log of log to the base 10 of y will be equal to, yes, log again to the base 10 alpha 2 plus beta 2 into log of x. So this equation is also linear, means log of y versus log of x. So here we can draw the graph. On x-axis take log of x to the base 10, y-axis log of y. Okay, and if the value of alpha 2 is between 0 and 1, so log of alpha 2 will become negative, so we will get intercept somewhere here, and this straight line will be like this. Okay, so here what is this? This is the intercept, and it is nothing but log of alpha 2, and slope is beta 2. Okay, again this equation is equation for the straight line where log of y varying with respect to log of x linearly. So again, if we compare this equation with our equation y is equal to a0 plus a1x, so here y is log to the base 10y, a0, that is intercept, is log alpha 2, and a1 is beta 1, x is log of x. So again, using linear regression we can find out values of log alpha 2 by using equation for a0. Similarly, we can find out beta 2 by using the equation for a1. Okay, so in following examples we will see all these things. So now we will solve one example here. Fit an exponential model to this given data. X is given 0.4 up to 2.3 and y is given 800 up to 3600. So now exponential equation means y is equal to alpha 1 e raised to beta 1 into x. So our aim is to find out alpha 1 and beta 1. So how to find out? First of all, we need to linearize this equation. How to linearize one exponential equation? We have seen in the previous discussion. So take natural log of y, it is equal to again natural log of alpha 1 plus beta 1 into natural log of e. Now natural log of e is equal to 1. So this equation will become ln of y, ln of alpha 1 plus beta 1. And this equation is similar to y is equal to a0 plus a1 x. Okay, sorry, I forgot here x, beta 1 into x into log and ln of e. So here also we'll be having x. Okay, so y is ln of y, a0 is ln of alpha 1, a1 is beta 1. So now again we need to make one table. Now you see carefully serial number, then xi and yi, these are the values which are given, and next column is ln of yi, because here we have ln of yi. and now xi will be xi. Okay, yi we are not going to use. Ln of yi is our yi. Okay, and this xi square is xi square, and here xi into ln yi is our xi into yi, which we use in our equations. Okay, so here we have taken log of this 800. It is natural log of 800, 6.684, then x square and xi, all these values are given in the table. Then finally here, what is this? This is the summation xi 8.3. What is this? 44.61. It is summation of ln yi, and this one is summation xi square, and this is summation xi yi. Okay, now we are interested in finding out a0, that is ln of alpha 1, and a1, that is beta 1. So what is the equation we use generally? It is a1, it is equal to n into summation xi into ln of yi. Just replace y with ln of yi, minus summation xi into summation ln of yi divided by n into summation xi squared minus summation xi whole square. So you put values here. N equal to 6, summation xi is 8.3, ln of yi 44.61, and all these values if you put, summation xi square is 14.09 and summation xi whole square. Now this summation xi whole square means this value 68.89. You put all these things, you will get alpha 1 is equal to, a1 is equal to 0.8202. Now this a1 is equal to what? a1, it is equal to beta 1. So this a1 is nothing but beta 1. We have found out beta 1, this one. Next, a0. What is the formula? a0 is equal to summation of ln yi upon n minus summation xi upon n. So again you put all the values, you will get a0 is equal to 6.3. What is a0? a0 is ln of alpha 1. So we have found out ln of alpha 1. So how to find out alpha here? We need alpha 1 will be equal to what? E raised to 6.3. So alpha 1 will be equal to 544.571. Now we will put these two values, alpha 1 and beta 1, in the equation, exponential equation. We will get y is equal to 544.571 into e raised to what, A202 into x. Okay, so we have got this relationship, and we can find out any intermediate value, okay, using this relationship. You put any value of x, you will get y. So for example, if x is equal to 2, you put x in this equation, you will get y is equal to 2808.4. okay, so you look in the table here, value of xi is 2, and according to given data it is 2900. okay, so there is slight difference in the value. In this table, this is the measured value 2 and 2900, and this value came from the equation. So this is the value from the model or from the equation. Okay, next I am giving you one assignment. It is very interesting problem. The population P of a small community on the outskirts of a city grown rapidly over a period of 20 years. Okay, so here T and P, time, that is number of years, 0, 5, 10, 15, 20, and population is 100, 200, 450, 950, 2000. So as an engineer working for a utility company, you must forecast the population 5 years into the future in order to anticipate the demand for power. Okay, employ an exponential model and linear regression to make this prediction. So how to find out here? Now this T is x and this P is y. So our equation, exponential equation, is y is equal to alpha 1 into e raised to beta 1 x. So the equation will become in place of y, right, P is equal to alpha 1 e raised to beta 1 into t. Okay, and unknowns are alpha 1 and beta 1. Take natural log of this equation. Ln of P will be equal to ln of alpha plus beta 1 into t ln of e. This will become 1. So our equation is ln of P is equal to ln of alpha 1 plus beta 1 t. If it is compared with our equation, y is equal to a0 plus a1x. So y is ln of P, a0 is ln of alpha 1, a1 is beta 1. So you can use the same procedure which we followed for the previous example and find out alpha 1 and beta 1. So after finding out alpha 1 and beta 1, you have to find out, now here it is given, forecast the population 5 years. 5 years means now after 20 years, that is at 25, t equal to 25, what is the population? Okay, so after finding out alpha 1 and beta 1, the equation, at t is equal to 25, what is the population? Find out. Now you solve one more problem related to power equation. Okay, so here the relationship between the stress tau and the shear strain rate gamma dot, okay, for a pseudoplastic fluid is expressed as tau is equal to mu into gamma raised to n, and the following data is given. Okay, so using a power law fit, find the value of mu and n. So gamma dot and tau, the values are given. What is to be done? Now this equation is power equation, like we have seen y is equal to alpha 2 into x raised to beta 2. So how we linearize this equation? By taking log to the base 10, remember, is equal to log to the base 10 alpha 2 plus beta 2 into log to the base 10 x. Okay, so similarly this equation can be linearized. Mu tau is equal to mu into gamma dot raised to n. So again take log to the base 10. Log tau is equal to log mu plus n into log of gamma dot. Okay, so when you compare this equation with our equation in the linear regression, a0 plus a1 x, so log tau is y and log gamma dot is x and log mu is a0 and a1 is n. So using these the equations for a0, a1, all these things you know how to find out. So you make one table, serial number and log gamma dot, this is our xi, then log of tau, that is yi, and log gamma dot into log, it is xi into yi, and this is xi square. So you take log of gamma dot and tau, these values, okay, and put in the table, find out all these things. So the final value summations are, so these values are calculated already. What is this? Summation xi, summation yi, summation xi yi, summation xi square. So after finding out all these things, you should get a0 is equal to log of mu. It is equal to 0.08987, and a1 is equal to n. It is equal to 0.4259. So we have got this n directly, and for the value of mu we need to take antilog, that is mu will be equal to 10 raised to this 8987. So mu is equal to 1.229, and the equation will become tau is equal to 1.229 into gamma dot raised to what? 0.4259 0.259. So now using this relationship we can find out any value of tau at any value of gamma dot. So for example, if you take gamma dot is equal to 75, put in this equation, we'll get tau is equal to 7.734. Okay, so look into the table. Here we have got this 70, it is 7.48. So at 75 what we are getting, tau is equal to 7.7. okay, and at 90 it is 8.59. so it is in very good agreement. Okay, thank you.